Okay, we're asked to find an empirical formula given the percent compositions. Empirical formula is the reduced formula. And really that's the only one we can get with just the percents. It's the reduced version that has the ratio. And then we need a molar mass if we want the molecular formula. So you may know that a formula will have the elements and it will show the ratio of the two. And so you might just think, maybe we could take these percents and put them there. And of course that looks funny because they're not whole numbers. But the problem with this is that these percents are in terms of mass. And usually on a compound down there we want the ratio of the particles, or the number of particles that are in a molecule or whatever. So we want to get this in terms of particles. And so to get it in terms of particles, what we do is we do a trick. Because in a way, these are in terms of mass, so you can think about them being in terms of grams. So we're going to do a trick, and that is to assume we have 100 grams of this compound. And if we do, then it allows us to take these percents and put them in a gram to gram ratio. In other words, if I have 100 grams of it, I know that 15.8 grams are carbon and 84.2 grams are sulfur, because that's what the percents told me. But I don't want a mass-to-mass ratio. I want this in terms of particles. And if we're going to talk about particles in chemistry, we should be thinking about moles. If I got a mole-to-mole ratio of these two, that would be the same as a particle-to-particle ratio, which is what I want for these numbers down here on my formula. So to get this to moles, I'm going to, of course, use molar masses or atomic weight off the periodic table. And when I do, I want to use more digits than I normally do. On a test, you will be given more digits for this, and I'll show you why. So I'm going to look at my periodic table and see. Okay, and so these are and the reason that I use more digits is that when we start looking at these numbers, we kind of got to see where they come off to full whole integers, and it's sometimes hard to judge when they don't quite, because everything's been rounded off, including these percents that we're given were rounded off. Anyway, so I'm going to write down a lot of extra digits here. Okay, so now we have a mole to mole ratio, which is a particle to particle ratio. And it wouldn't be that wrong. It'd be a little closer to put these numbers here. But the thing is, we like to have integers there. And so the next step that we take is we divide by the smaller of these two numbers. So in other words, I'm dividing them both by the 1.3155. And here I'll get a 1. And here I get okay, and it doesn't come out to exactly 2. But at this point it should come out to whole numbers. And if it doesn't, it's because, and it comes really close, it's because these numbers are rounded off ahead of up here. Not just the atomic weight that I put in, but the original percent that I put in. So if it comes to within 3 sig figs, I had 3 sig figs here, of rounding to an exact number, then This is actually the number 2. Okay, and so there we have our empirical formula. Our empirical formula for this will be CS2. Once we have the empirical formula, we can use a molar mass to get to the molecular formula, which is the true formula. And so we're given the molar mass. Remember that the molar mass goes with the molecular formula, the true. And so what we have to ask ourselves is, we'll take this empirical formula and multiply it by some factor to get up to this molecular formula. And so what we'll do, first we'll calculate the molar mass of the empirical, which was CS2. And then again, we're saying, what multiple do we use to get up to 152? And the multiple, or the factor, sometimes call it, we'll get that by dividing the molar mass of the compound divided by the molar mass of the empirical formula. In other words, I'm going to take 152 and divide it by 76.2. And it may not come out exactly to a whole number, but that's just because of rounding. This comes out to about 2. So this is my factor. And so to get my molecular formula, I say 2 times whatever the empirical was, which was CS2. So my molecular formula is C2S4.